In this lab, we're going to be going over intermolecular forces and how they affect certain properties. And the property that we're going to look at in this lab is surface tension. Surface tension is the ability for molecules to attract to each other, pull together, and lower the surface area that it covers. So let's see what happens between alcohol, isopropyl alcohol, and water. I'm going to start with water on this penny. And hopefully you can see that my first drop is going to dome up, and I have 2 drops there. Let's see how many drops we can fit. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and it spilt over. So it held about 24 drops, and that's because these water molecules cling very tightly due to their hydrogen bonding, which is a really strong intermolecular force. Now I also have here isopropyl alcohol, which has hydrogen bonding too, but it only has 1 spot for hydrogen bonding because there's only 1 hydrogen bonded to an oxygen, where in water there's 2 hydrogens bonded to an oxygen. So we should see a lower intermolecular force. And if we're talking about our surface tension, that means we should have a lower surface tension because they're not attracted as well. So we got 24 water on the penny. Let's see how many isopropyls we can get. 1, let's go this way, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it spilt over. So we got 24 on here, drops hold together roughly, and we got 12 roughly here to hold together. So these attractive forces are much weaker holding them together. Why? Because there's less intermolecular forces. There's only 1 site for hydrogen bonding here, and there's 2 sites for hydrogen bonding here. So basically we have double the hydrogen bonding. So the first part of your lab talks about spreading. Which one spread further? Well, you can see the isopropyl didn't hold as much, so we would assume that would spread farther. And I'm going to move to a new spot. And here is my water. If I just put a drop or 2, you can see it doesn't spread very much. It balls up. It's lovely. My isopropyl alcohol, 1, 2, it spreads much further. And that's part of your data table. And why does it spread further? Because those attractions are much weaker than the attractions in water. So now this is going to be hard for you to see, but maybe you can see that the isopropyl alcohol is already pretty much evaporated. So in your lab, it asks which one would evaporate faster, and that would be isopropyl alcohol. Why is that happening? Again, we're going from a liquid to a gas. In a liquid, those molecules are touching, and there's attractive forces holding them together. The weaker the attractive forces, the faster they can break apart and go into gas. Isopropyl has the weaker intermolecular forces, and so it turns into gas a little faster. And the last thing it tells you to do is to put 1 of each on the back of your hand. So isopropyl alcohol is hand sanitizer, which you guys should all have at home. So if you put water on the back of your hand and isopropyl alcohol or hand sanitizer on the back of your hand and wave it around in the air, you will notice that the isopropyl alcohol hand, or the hand sanitizer hand, is going to get much colder. So in order for those forces to break apart, it takes a little bit of energy and it pulls it out of your hand. They're flying apart faster, and isopropyl alcohol takes more energy and that hand feels colder. So fill out your data table, answer the rest of these questions with your notes and this video.